Hello everyone. Slav Karen. I'm Katitan Bash. Lem video we're going to talk about chapter 7 section 3 using chemical formulas. We all know that in section 1 we learned about names of ionic and molecular compounds and we learned about their formulas, isn't it? We said chemical formula is very important in chemistry. We learn about their names. Now we know how to name, how to write the formula of any compound, especially binary, ionic, binary, molecular compounds. And in section 2, we learned about oxidation numbers. Oxidation numbers are very important in chemistry as well, because it tells us how electrons are distributed in molecular compounds and polyatomic ions. Okay, here guys, we're going to use chemical formulas to find the molar masses and especially to know the amount of a substance in a chemical reaction. Later you will understand the importance of chemical formula. So in this section we're going to use chemical formulas for many concepts in chemistry. The first one is formula mass, and we all know what's chemical formula, isn't it? We learned in chapter 6 and in also chapter 7 section 1 they indicate the elements as well as the relative number of atoms or ions of each element present in a compound, like H2O. This is a chemical formula. NaCl is also a chemical formula. Both of them, H2O is the molecular formula, NaCl is formula unit, but both we call them chemical formula. Okay, so what's the formula mass? Formula mass, we can say, is the mass of a formula. So the formula mass of any molecule, formula unit example, NaCl, molecule like H2O, or ion like PO4, Basha, like PO4 3 negative. So this is also a formula. So formula mass of each one of these is what is equals to the sum of the average atomic masses of all atoms represented in its formula. So we need to know the number of atoms, okay, in a formula, and then the sum of the mass of the atoms in a formula, it equals to the formula mass. That's very easy. We learn the average atomic mass, or we can, most of the time we just say atomic mass. Atomic mass is the mass of one single atom of an element, okay? This actually is the average. We learned this average, we mean the average atomic mass of all isotopes of an element. So here we just called atomic mass. So an example, find the formula mass of H2O. This is one of the common questions that asks about formula mass. Guys, before when it asks for formula mass, we need to know number of atoms that represented in its formula. There are how many hydrogens? There are 2 hydrogens and 1 oxygen atom. Mass of 2 hydrogen with mass of 1 oxygen, it equals to the formula mass of water, H2O. So first of all, in the formula of H2O, there are 2 hydrogen atoms and 1 oxygen atom. This is the first step you must know. There are how many? There are 2 hydrogen atoms and 1 oxygen. The first step. So we're going to know the first mass of 2 hydrogen atom, mass 1 oxygen atom. Guys, in the periodic table, you see these squares. Each square in the periodic table gives you information about the element. Element symbol, element's name, and atomic number. And we have a number, guys. This number below the name of the element tells us what? The mass of one single atom of that element, or the average atomic mass. So the average atomic mass of one single hydrogen atom is 1.007994. Oxygen is 15,999. Basha? We know that we call that for this number, when we say that atomic mass is AMU, 1 AMU, if we round it up. 15.999, we just can't say just 16. We can't round it to 2 decimal places. Basha? So we just say AMU, okay? Bash. We have 2 hydrogen atom, okay? And we have 1 oxygen atom, okay? Bash. The mass of 2 hydrogen atoms equals to, there are 2 times hydrogen mane 2 times the atomic mass. It means when you say atomic mass of hydrogen, means mass of 1 hydrogen atom. Mass of 1 hydrogen atom is, we can say just 1 AMU, Basha, 1 AMU. So the mass of 2 hydrogen is 2 AMU, okay? The mass of 1 oxygen atom, we already know atomic mass. Atomic mass is the mass of 1 oxygen atom. So 1 times, we can just round it to 16 AMU. Basha, later I will not use that unit, just I want you to know that the unit of atomic mass is AMU. We don't use gram, kilogram. We know that they have large units. For mass of an atom, we are the mass of subatomic particles, we just use AMU, okay? So it equals to 16 AMU. Mass of 1 single oxygen atom is 16. Bash. Now we know the mass of 2 hydrogen, 1 oxygen. Total, it says, sum of the average atomic mass of all atoms we have done for we have 2 hydrogen, 1 oxygen. So these are all atoms in that formula. The sum of the, so 2 AMU, Basha, plus 6 AMU, mass of 2 hydrogen and sum of the mass of 2 hydrogen and 1 oxygen equals to 18 AMU. So what's this number? Is the formula mass of H2O. Basha? So this is 18 AMU is the formula mass of H2O. We can say this is the mass of 2 hydrogen and 1 oxygen atom. This is how we find the formula mass. Okay? That's it. So this is how I have done this. Another example, KClO3. So guys, in the exam, I will give you the atomic masses. Basha? Atomic mass will be given. Look, find the formula mass of potassium chlorate, ClO3. The first step, as I said, you must know there are how many atoms of each type. We have 1 potassium, 1 chlorine, 3 oxygen, isn't it? We have 1 potassium, 1 chlorine, and 3 oxygen. Just do it like me. So we have 1 potassium atom, 1 chlorine atom, 3 oxygen atoms. So 1 times what? The atomic mass of what? Galena atomic mass, mass of 1 potassium atom. So 1 potassium is 39.10. So 1 times 39 is 39.10 what? AMU, Basha. So 39 is also AMU. 1 chlorine, 1 times the chlorine is 35.45 AMU. So again, equals to 35.45 AMU. Okay, good. We have 3 oxygen. This is very important. 3 times the atomic mass of oxygen. These informations, guys, will be given in the exam. So 3 times 16 equals to 48 total. So we're going to add these together. 39 plus 35.45 plus 48, it equals to 122.55. Okay, AMU, this is the unit of the formula mass. We're talking about the mass of atoms. We use AMU. So this is the formula mass of potassium chlorate. That's it. Guys, look at here, just a note. Look, that's easy. We have 2 hydrogen, 1 sulfur, 4 oxygens. Guys, look at here, calcium nitrate. We have how many calcium atoms? 1. What about nitrogen? Look, guys, we have 2 NO3. This number is for everything inside the parentheses. It means we have 2 nitrogen and 6 oxygens. Just do it by yourself. Here, guys, we have a polyatomic ion. We can't find the formula mass of our polyatomic ions. But just know, don't care about the charge. Basha? Just imagine we have PO4. Why we don't care about the charge? Means 3 electrons have gained, but mass of the electrons, they do not affect the total mass of the PO4 polyatomic ion. So electrons, we don't care. We don't count the mass of electrons. So just imagine we have 1 phosphorus and 4 oxygen. Mass of 4 oxygen with mass of 1 potassium. Sum of the mass of these is equals to the formula mass of PO4 polyatomic ion. That's it. Masha? Guys, the mole. Mole is very important in chemistry. So, to understand the amount of a substance when 2 chemical substances, they react, to know their amount of substance. So mole is very important. That tells us, they give us information about the amount of substance. So what's mole? The mole, so this is the symbol of the mole, just MOL. Like, for example, gram, we use just a small g. Is SI unit of measurement. Why? We use it for the amount of chemical substance. So mole, they give us information, the unit to measure amount of a chemical substance. That's it. This is the definition. In chemistry, particles such as atoms. Guys, when you say particles in chemistry, we mean atoms, we mean molecules, we mean ions. These particles in chemistry, they counted by the mole. How? Guys, you all know 1 dozen, isn't it? In daily life, we use the word of dozen for what? Instead of saying 12 things, okay? Asha? 1 dozen equals to 12 things. Basha? For example, 1 dozen of pencil equals to 12 pencils. Instead of saying 12 pencils, it's much easier. We just say a dozen of pencil. But in chemistry, we don't use dozen. Dozen doesn't give us any information. This is why we don't use dozen. So when we say 1 dozen, 12 atoms. 12 atoms mass, we can't see it, doesn't affect the reaction that much. So we can't see the 12, for example, 12 hydrogen atoms. We can't, it's difficult to deal with it. Masha? So we don't use dozen because masses of hydrogen, they're very, very small. So we must have a bunch of atoms, then we can see it, then we can use it in a chemical reaction. So we use mole. 1 mole, guys, in chemistry equals to Avogadro's number, which is 6.02 times 10 to power 23. This is 1 mole. Basha, 1 mole equals to Avogadro's number. Kata, this number, guys, we called Avogadro's number. Kata, 1 mole equals to Avogadro's number. What's Avogadro's number? Is the number of particles in exactly 1 mole of a pure substance. Is the number of substance where? In 1 mole of a substance. Basha, this is the definition of Avogadro's number. So what's important you to know that 1 mole equals to 6.02 times 10 to the power 23 particles. Particles can be atom, molecule, ions. Basha? So in chemistry, instead of saying that big number, guys, look at that large number, 602 zillions particles, atoms, that instead of saying that big number of atom, molecule, ions, we just say 1 mole. So when we say 1 mole, you must imagine that we're talking about Avogadro's number. We're talking about 6.02 times 10 to the power 23 particles. Okay, that's it. As I said, the mole is a counting unit like a dozen. 1 dozen equals to 12 things, but instead of dozen, we use mole in chemistry. 1 mole equals to 6.02 times 10 to the power 23 particles. It's counting unit. It's about the number. Basha, that's it. Molar mass, relating mass to number of atoms. Molar mass is also important. Is the mass in grams of 1 mole of a substance. If you have 1 mole of any substance, 1 mole of hydrogen, 1 mole of water, 1 mole of table salt. So when you say 1 mole of water, you understand that we're talking about 6.02 times 10 to the power 23 molecules of water, H2O. So, but what about mass of 1 mole? Mass of 1 mole of any substance we call molar mass. And instead of saying mass of 1 mole of something, we just say molar mass. Is the mass in grams of 1 mole of a substance. Because 1 mole of a substance never equals to a kilogram. So we just use a gram, okay? Molar mass is written in units of gram per mole. This is the unit. We just use gram and 1 mole. We mean that mass of something in 1 mole, gram per 1 mole. Asha, that's it. The molar mass is numerically, that's important, guys, is equal to atomic mass in grams. For example, the atomic mass of lithium is 6.94 AMU and its molar mass equals to 6.94 gram per mole. Guys, you must understand something here. That lithium, for example, it's just an example, it's just an element. Do you see this number? Yes, we have just learned this is the atomic mass of 1 single lithium atom. We know lithium's atomic number is 3. There are 3 protons and 3 neutrons and 3 electrons. Mass of that atom is what? Is 6.94 AMU. We have just learned this. Mass of 1 mole of lithium. 1 mole of lithium means 6.02 times 10 to the power 23 lithium atoms. That zillions of lithium atoms. Their mass is 6.94 gram per mole. Guys, look, mass of 1 single atom, mass of Avogadro's number of lithium atom, their mass is the same numerically, but different units. This is gram, this is AMU. AMU is very, very small. Okay? So here you must know that. For example, you just say 10 centimeter, 10 kilometer. Both they're 10. But numerically they're same, but different units. 10 centimeter is very small compared to 10 kilometers. Also 6.94 gram is very larger than the 6.94 AMU. Okay, that's it. So atomic mass, molar mass of any element, they're the same numerically, but different units. Okay, so guys, molar mass, mole of one element of, we have 118. They're given, they're known. We know the mole of any element, mass of 1 mole of any element. Okay, they're given in the periodic table where we can find that number below the name of the element. Okay, guys, we change, for example, we say 1 meter equals 200 centimeter. So also we can change centimeter to meter, meter to kilometer. So in chemistry also we can change mole to gram. So we have an amount of substance, there are how many moles in that substance. We have 10 gram of a substance. We want to know there are how many moles in that. It's about number. Okay, so how we change gram to mole or mole to gram? We have rules, guys. This is the rule that's given in the book. If you have amount of element in mole, and how we change mole to gram, multiply by the molar mass. Basha, it gives you mass of element in grams. If you have mass of element, how we can change it to mole, divide by the molar mass. So you must know these rules to know how to change mole to gram, gram to mole. Look at this example, guys. What is the mass in grams of 2 mole of helium? If you have 2 mole of helium, what's the mass of 2 mole of helium? First of all, guys, you must know the rule. It asks for what? For mass. How we can find mass? Mass equals 2 mole times molar mass. You must memorize this rule. Whenever it asks for mass, to find mass, we always use that rule. Mole times molar mass. Do we have mole? Well, we have 2 moles. Bash. 2 mole. Just write it down. Guys, molar mass, they're always going to be given for an element. For compounds, later we'll talk about, you need to just do some calculations, then you can find. So molar mass will be given. So in the exam, I tell you that molar mass of helium is 4 gram per mole. Molar mass of helium is 4 gram, means 1 mole of helium, its mass is 4 gram. What about 2 mole? We can say just that. So 2 times 4 gram per mole, and in 1 mole. So 2 mole and mole, they cancel out each other. 2 times 4, 8 gram. So this is what I want in the exam. 8 gram of helium. Means that 2 mole of helium, 2 moles of helium equals to 8 gram. Or we can say in 2 mole of helium, we have 8 gram. Okay? In 1 mole is 4. In 2 moles, it must equals to 8. That's it. What's the mass in grams of 3.50 mole of the element of copper? What's given? Mole. What's a noun? Mass. So we're going to change mole to mass. Mole is given, mass is a noun. What rule do I use? Mass equals, this is the rule that I use to find mass. Mole times molar mass. What's the mole? Look, it says 3.50 mole of copper. Mole is 3.50 times. What's the molar mass? Look, molar mass of copper will be given in the exam. So 63.546 gram per mole. Here also the unit of mole, we need to write it. Mole and mole, they cancel out each other. So 3.50 times 63.546 is equals to 222 gram of what? Of copper. So 3.5 mole of copper equals to 222 gram. In 3.5 mole of copper, we have 222 gram of copper. Masha? That's it. We have practices. Then we use the same rule, just we have mole of iron, mole times the molar mass of iron will be given in the exam. You get the mass of iron will be 126 gram. You have 0.375 mole of potassium, and then molar mass of potassium times the mole of potassium, you get the mass in grams of potassium. We use the same rule. Okay, here guys, that's a different question. It says a chemist produced 11.9 gram of aluminium. How many molecules of aluminium were produced? Bash. What's given? Gram. Just know, guys, this is G is the what? Is the symbol of gram. So it's the gram is the unit of mass. So what's given? Mass is given. So then it asks for how many moles. So mole is unknown. So we change mass in grams to mole. Basha? So given, mass, unknown, mole. The rule, guys. This, for finding mole, mole equals mass divided by the molar mass. So what's the mass? Mass is 11.9. Sorry. 11.9. Okay. Molar mass of aluminium will be given. It equals to 226.98. So total, you get what? The aluminium is 0.44 what? Mole of aluminium. Rasha? Guys, we have gram here. We have gram per mole down here. Gram and gram, they cancel out here. Just divide these two numbers, you get the amount of mole. That's it. To find mole, mass divide by molar mass. But to find mass equals mole, mole times molar mass. Guys, here, the practice, how many mole of calcium are in 5 gram of calcium. Again, we use the same rule, 5 gram, put it on the top, molar mass of calcium will be given. Okay, then how many mole of gold are in that number? 10 to power negative 10 of gram of gold. Here again, you put that number on the top, molar mass of gold, divide by 100. Gold is 196.97. Just divide by this number. Okay, 197.96, sorry, 0.97. Just divide these two numbers together, you get what? 1.8 times 10 to the power negative 12 mole of gold. That's it. They're easy, just you need to know the rules. That's it. Conversion using Avogadro's number. Look, guys, we have not used Avogadro's numbers yet, so we're going to use it. Avogadro's number can be used to find the number of atoms of an element from the amount in moles. So it says you can use Avogadro's number to find number of atoms of an element from the mole. Means if I give you mole, you can find the number of atoms by using Avogadro's number, or to find the number of element in moles from the number of atoms. If I give you number of atoms in the exam, you can find the amount of mole. Look at here, guys. Look at these examples. Here, guys, number of atoms. If given, you can find mole by using Avogadro's number. Number of atoms of element divided by the Avogadro's number. Avogadro's number, you must know it. You must memorize it. It equals to 6.0, 22 times 10 to the power 23 atoms. You're gonna put it here, but if I give you number, you can find mole. Or mole times Avogadro's number, you can get the number of atoms. Number of atoms of the element equals to mole So if I give mole times Avogadro's number, you get what? Number of atoms here. So you can't just memorize one of these two rules, you can get the other one from the one you memorize it. Or you can use that rule, number of atoms of the element. Guys, we're talking about number elements. We have not talked about mole and number of molecules, amount of compounds yet. We're just talking about elements. Later we'll talk about compounds. So that's why number of atoms of element times, divided by the Avogadro's number of atoms here, look, divide by Avogadro's number, you get amount of element in mole. Amount of element in mole, multiply by Avogadro's number, look, you get what? Number of atoms. That's it. You need to memorize these two rules. They're important. So you just need to memorize these four rules. These two, and mole equals to mass divided by molar mass, and mass equals mole times molar mass. Okay, so you can just memorize this. Okay, up to you. Here, guys, how many moles of silver are in 3.01 times 10 to the power 23 atoms of silver? So you, in the exam, you must know that it asks for what? How many mole? So we have two rules. Mole equals mass divided by molar mass, or mole equals to number of atoms of an element divided by the molar mass. So here what's given? Number of atoms. So we're not going to use mass divided by molar mass. We just going to use what? Mole, it asks for mole. Mole equals, I think we have the rule, yeah. Number of atoms of the element divided by Avogadro's number. So number of atoms, 3.01 times, let me just, times 10 to the power 23 divided by the Avogadro's number, 6.02 times 10 to the power 23. So 10 to the power 23, 10 to the power 23, they cancel out each other. So you just need to divide these two numbers together. So it equals to 0.5. What? Mole. Basha? So 3.01 times 10 to the power 23 atoms of silver equals to 0.5 mole. So that number is half of the Avogadro's number. So it must equals to 0.5 mole. Okay, that's it. But here, guys, number of atoms. Look, what's the mass in grams of gram of 1.20 times 10 to the power 8 atoms of copper? What's given? Number of atoms. It's written atoms, means number of atoms is given. What's a noun? Mass in grams. Bash. You know, guys, I told you, you have only one rule to find mass. Mass equals to mole times molar mass, isn't it? Bash. Do you have mole? Molar mass, yes, will be given. This is molar mass of copper. Times what? 63.55. You can just round it to two decimal places. Gram per mole. Bash. But to find mass, there must be only one noun, not two nouns. So mole is a noun, but we can find it by number of atoms. Mole equals number of atoms of element divided by Avogadro's number. So just use that. Number of atoms, we find mole first to find mass. Number of atoms, 1.20 times 10 to the power 8 divided by 6.02 times 10 to the power 23. Basha. Just divide these two numbers together first. Just do this. It equals to 0.2, then times 10 to the power, this is going to be 15, 23 minus, so you're going to do like that, 8 minus 23. Basha? 8 minus 23, it equals 2. 0 point, it equals 2. So you take this, guys, you bring this up, it becomes negative. You have learned. So it equals to 0.2 times 10 to the power negative 15. That's it. Okay? But if we use scientific notation, we're going to just write it like that. 2 times 10 to the power, because that number is m in scientific notation, it must be 1 or less than 10. Between 1 to 10 can be 1, but can't be less than 1. Cannot be 10, but can be less than 10. So it becomes, you make this one bigger, you make this one smaller, will be negative 16. Masha? You know this, you have learned this. That's it. Now we have just found the what? We have found the mole. So mole equals to, mass equals, so we have found mole. Mole is equals to this number. So 0.2 times 10 to the power negative 15 times 63.55, you get this number. Look, 0.2 times 10 to the power negative 15 times 63.55 gram per mole, mole, they cancel out. It equals to 1.27 times 10 to the power negative 14 gram of copper. So guys, if in the exam asks to mass, use this rule. But if molar mass will be given, if it asks for mole, but a number of atoms are given, use this rule to find mole. After you find mole, you put in this equation. So mole times the molar mass, you get the mass in grams. Masha? This is 1.27 times 10 to the power negative 14 gram of copper. So now you need to use two rules. Okay? Guys, here practice, there are two practices. So they're all easy. We use the same. We can solve all of them by using these 4 rules. You must memorize it. Guys, by these 4 rules, we can solve all the questions. But guys, here for third one here, it says what mass of gold, it asks for what mass of gold contains the same number of atoms as 9 gram of aluminium. So what's a noun? Mass of gold. What's given? 9 gram of aluminium. But it has given a hint here, the same number of atoms as 9 gram. We have how many? What's the mass of gold in same number of atoms as 9 gram? Pasha, there are how many atoms in 9 grams? Because it's in the same number of atoms. So first we need to know the number of atoms. Then when the number of atoms are the same, we can find the mass of aluminium. But here, guys, we can use a short way. It says same number of atoms. So for example, when you say 1 dozen of pencil equals to 12 pencils. When you say 12 pencils equals to 1 dozen. What about 12 markers? Both equals to, is also equals to 1 dozen. So when the number of atoms of 2 substances are the same, mean their moles are the same too. Take this note. When atoms are the same, atoms of 2 different elements are the same, their moles are the same. Pasha. So means 9 gram of aluminium, we're going to change to mole of aluminium. Mole of aluminium, mole of gold are the same. Why? Because it says in the same number of atoms. So here we have gram of aluminium. First, we change gram of aluminium to mole of aluminium. Why? Because mole of aluminium and mole of gold are the same. Kata. So we change 9 gram of aluminium to mole of aluminium. So then mole of aluminium equals to what? A mole of gold. Then we change mole of gold to gram of gold. Rasha? Just know that when it says in same number of atoms, means say moles. باش 9 gram of aluminium. So first, mole equals to what? Mole equals to, we have mass of aluminium. Mass of aluminium is 9 gram of aluminium. What's the molar mass of aluminium? 26.98. Asha, divide these two numbers together, you get what? 0.33 and 34 what? Mole of aluminium. Bash. Esta, we know mole of aluminium. Mole of aluminium equals to mole of gold, because the question tells you in the same number of atoms. Same number of atoms. We can't change that mole of aluminium to number of atoms of aluminium, and we use the same number of aluminium to gold and find mole of aluminium and change to mass. But here we don't need to do this. Moles are the same. So we're going to use that. We have how many mole of gold now? We have 0.33 mole of gold. So this is mole of aluminium. So now we have mole of gold. We change to what? 2 gram of gold. So mass in grams, mass of gold equals to what? Mass equals to mole times molar mass. What's the mole of gold? We have just found 0.33, 34 mole. Because mole of aluminium, mole of gold are the same. 0.33, 34, Pasha, mole times what? Molar mass. What's the molar mass of gold? Is 196, yes, 96.97. Total, it equals to what? 66 gram. So this is mole, this is gram per mole. Asha, this is the molar mass. Mole and mole, they cancel out each other. Total, we have 66 gram of gold. And in 9 gram of aluminium equals to 66 gram of gold in the same number of atoms. And so there are how many gram of gold in 0.33 mole of gold? We have 66 gram of gold. That's it. Others, guys, they're easy. We just use the rules. We just use the steps that we have done in previous problems. Okay? Yeah, 66. Molar mass of compounds, guys. Molar mass of elements, we all know it. In the periodic table, they're given. 1 mole of any element, we know it, their mass. What about molar mass of a compound? Okay. The molar mass of a compound is calculated by summing the mass of elements present in mole of the molecules or formula units that make up the compounds. Okay? For example, 1 mole of water molecules contains exactly 2 mole of hydrogen atoms and 1 mole of oxygen atoms. Okay. Look, guys, we have, what's the molar mass of H2O? We must know, when you say molar mass of water, means 1 mole of water. First of all, we need to know there are how many mole of oxygen and hydrogen in 1 mole of water? Because it says molar mass, means 1 mole, right? Mass of 1 mole of water, H2O compound. So means 1 mole. Bash. In 1 mole of H2O. H2O. Asha? Because it says molar mass, mass of 1 mole. So in 1 mole of H2O, we have how many mole of hydrogen? How many mole of oxygen? First, we need to know that. 1 mole, we can say 1 times 2. 1 H2O means how many? 2 mole of hydrogen. How many mole? Or we can say 1 times, this is 1. 1 times 1, 1 mole. 1 mole of oxygen. Basha? So here it says molar mass of compound is calculated by summing the masses of element present in a mole of the molecules. In a mole, in 1 mole of molecules. Basha, in 1 mole of H2O, we have 2 mole of hydrogen. Basha, 2 mole of hydrogen, 1 mole of oxygen. Basha. So we have 2 mole of hydrogen and 1 mole of oxygen. So for 2 mole of hydrogen, we have 2 mole. 2 times what? Molar mass of 1 mole of hydrogen. Or molar mass of hydrogen چند? 1 gram per mole, isn't it? 2 what? Here 2 mole. 1 times 1, sorry, 2 times 1, it equals to 2 gram. Gram, they cancel out. Sorry, mole and mole, they cancel out each other. We have 1 mole of oxygen. 1 times 16 gram per mole. Masha? Here is 1 mole. Mole and mole, they cancel out each other. It equals to 16 gram. In 1 mole of oxygen, there are 16 grams. In 2 mole of oxygen, there are 2 grams. So total molar mass of H2O, it equals to the sum of the masses of the elements in 1 mole of molecule. In 1 mole of H2O, we have 2 gram of hydrogen, 16 gram of oxygen. These two all together, 2 plus 16, 18 what? Gram per mole. Because this 18 gram is a molar mass of water in 1 mole of H2O. Basha, the molar mass of H2O, it equals to 18 gram per mole. But guys, this number is very familiar for us, isn't it? Do you remember we found just molar mass of H2O? Mass of 2 hydrogen and 1 oxygen equals to 18 AMU. Here, guys, molar mass, here, do you remember we said molar mass and atomic mass are the same? Here also, formula mass and the molar mass, look, here I have written, molar mass is numerically equal to the formula mass. Formula mass of H2O is 18 AMU. Its molar mass is 18 gram per mole. Okay? That's it. So molar mass of a compound means mass of 1 mole of a compound. 1 mole of H2O equals to the mass of 2 hydrogen and mass of 1 oxygen. Mass of 2 mole of hydrogen, mass of 1 mole of oxygen. But in formula mass, we were saying mass of 2 hydrogen atom, mass of 1 oxygen atom. Here we don't say, we just say in 1 mole of H2O, because we're saying molar mass, we have 2 mole of hydrogen, 1 mole of oxygen. Mole of hydrogen times molar mass of hydrogen. Mole of oxygen times molar mass of oxygen. Molar masses of each element will be given in the exam. I think we use the same steps to find formula mass. For example, for barium nitrate, we have how many barium? It's very important. Here, guys, molar mass of barium nitrate means mass of 1 mole of barium nitrate. 1 mole of barium nitrate compound is compound. So in 1 mole of barium nitrate, we need to know how many moles of barium we have. 1 mole. How many nitrogen? 2 nitrogen. That number is for everything inside the bracket. Means 2 times 1, 2. 2 times 3, 6. We do it like that. So we just say we have 1 mole of barium, 2 mole of nitrogen, 3 mole of oxygen. Here, look. 1 mole of barium, 2 mole of nitrogen, 6 mole of oxygen. 1 mole of barium times molar mass of barium, gram per mole. Mole and mole, they cancel out each other. 1 times 137.33, it equals to that number. 2 mole of nitrogen times 14, 2 times 14, 28.02 gram of nitrogen, 6 times 16, 96 gram per mole, total 261.37 gram per mole, a smaller mass of barium nitrate. 1 mole of barium nitrate, 1 mole of barium nitrate compound, its mass is, it contains 261.37 gram. Okay, that's it. Here, guys, it says how many moles of atoms of each element are there in 1 mole of the following compound. Calais, how many moles of atom in 1 mole of the following compounds? We just, it's like when you say molar mass, it means 1 mole of it. 1 mole of aluminium sulfide, we have 2 aluminium, 2 mole of aluminium, 3 mole of sulfur. In 1 mole of sodium, 1 mole of nitrogen, 3 mole of oxygen. Here we have 1 mole of barium, 2 mole of oxygen, 2 mole of hydrogen. So it's just an information to find molar mass. That's why it says find molar mass of each of the compounds listed in item 1. For mole of aluminium sulfide, 2 mole of aluminium, 2 times molar mass of aluminium, 3 times molar mass of sulfur, which is 32. Add them together, you get the molar mass. We use the same rule, same method to find formula mass. Molar mass as a conversion factor. Guys, it's same. If we're talking about compounds. If you convert mole to mass in grams of a compound, we just use the same rule, mass, mole times molar mass. If you convert mass, okay, this is double S, in gram to mole of a compound, we use this rule. Same as the rules that we use to change mass to mole, mole to mass of elements. Asha? That's why here it talks about this. Asha? Talks about these 2 rules. No need to memorize anything there. Just you need to know the rules, guys. Look. Look, do you remember number of atoms of element in compound? We just say number of molecules or formula units of a compound times the Avogadro's, divided by Avogadro's number. You get amount of compound in mole. So number of atoms of element in compound, Basha, times the divided by Avogadro's number, you get the amount of element in compound, Basha, of element in compound, number of compounds, Basha, and we find the mass of compound, we find the mole of compound, the elements inside of a compound. Okay, we use the same rule. What's the mass in grams of 2.50 mole of oxygen gas? Here, guys, it asks for mass in grams. What's given? Mole is given. You can't just recognize it by its symbol. Okay, so mass in grams equals mole times molar mass. Okay, so what's the mole? Mole is given 2.50. That's easy, isn't it? Times molar mass. What's the molar mass? Molar mass of oxygen gas. Here, guys, when to know molar mass, you need to know the formula. So oxygen gas is not O, it's O2, guys. It's an element. So oxygen, molar mass of oxygen, akate chi of oxygen, akate 2 of O2, sorry, 2 times what? Molar mass of 1 oxygen is 16. Total 32 gram per mole. Basha? So here it talks about 2 oxygens. So it's 32 gram per mole. So molar mass of O2 is 32 gram per mole. So total it equals to 80 gram of O2. So formula is important. It's not, it says oxygen gas. Oxygen gas is an element. We all know it. Okay, that's it. Sample problem 1 to 13. That sample problem is easy. It's not difficult. It looks difficult, but it's not difficult. So guys, we have ibuprofen. It's the formula of ibuprofen. Is the active ingredient in many non-prescription pain relievers. Its molar mass is 206.31 gram per mole. It's a compound. Its molar mass is given. You don't need to find it. So the formula of the ibuprofen is given. You don't need to write the formula. So there are three questions we need to find. It says if the tablets in the bottle contain a total of 33 grams. We have a bottle of ibuprofen. Contain 33 grams. How many moles of ibuprofen are in the bottle? What's given? Grams given. What's a noun? Mole is a noun. So mole equals to mass divided by molar mass. What's the molar mass? Molar mass is given. So look. So it tells you that to convert ibuprofen mass to moles, multiply by the molar mass. Okay? So that is, so mole equals mass divided by the molar mass. So 33 grams we have it. Divide by 206.31. It equals to 0.16 mole of ibuprofen. Molar mass, where did we get this? It's given here. And the mass is given. Mass divide by molar mass, you get the mole. That's easy. Second question, how many molecules of ibuprofen are in the bottle? Here, in the bottle, we have 33 grams. 33 grams equals to 0.16 mole. Masha? We have 33 grams. That 33 grams in the bottle equals to 0.16 moles. Now that's for number of molecules in 33 grams. Or we can say in 0.16 mole. We have 0.16 mole in the bottle. There are how many molecules of ibuprofen are in the bottle? So here, so we change mole to molecules. How we change mole to molecules? Okay, so mole is given. Mole times Avogadro's number, you get the number of molecules. Okay, we have the rule. So mole of ibuprofen multiply by the what? Avogadro's number, you get the molecules of ibuprofen. So 0.16 mole times what? Avogadro's number, you get 9.6 times 10 to the power 22 mole of ibuprofen. So in the bottle, we have how many moles of ibuprofen? We have 9.6 times 10 to the power 23 molecules of ibuprofen. Okay, so that's easy. The last, guys, it says, what is the total mass in grams of carbon in 33 grams of ibuprofen? So it asks to the mass of only carbon in grams in 33 grams. In that bottle, we have 33 grams, we have 0.16 mole, we have 9.6 times 10 to the power here, 2 molecules. But now it asks only for mass of carbon. Carbon is made of ibuprofen is made of 13 mole of carbon, 18 mole molar mass. 1 mole of ibuprofen, we have 2 mole of oxygen. But here that's for mass of carbon in 0.16 mole of ibuprofen. باش. So إما أزانين كلام 1 mole of ibuprofen, C13 H18 O2. Basha, ليك mole. Do you remember? We were, for finding molar mass, we're going to do it like that. In 1 mole of ibuprofen, align 1 times 13, 1 times 18, 1 times 2. We have how many carbon? We have 13 mole of carbon, mole of carbon. So we have how many mole of hydrogen? Again, 18 mole of hydrogen, 2 mole of oxygen. In what? In 1 mole of ibuprofen. But here, if we say, so here it says, how many total mass of gram of carbon in 33 gram of ibuprofen? 33 gram equals to 0.16 mole, right? So in 0.16 mole of ibuprofen, we have how many mole of carbon? So just a minute. So 0.16 times 13 carbon, mole of carbon. So we get the mole of carbon. 0.16 times 13, it gives us a number which is 2.08 mole of carbon. Basha? Means 0.16 mole of ibuprofen, there are how many mole of carbon? 2.08 mole of carbon. Basha. How we can find the mass or mass in grams of any substance? Mass equals mole times molar mass. So what is mass? We can say mass of carbon equals mole of carbon 2.08 times, what's the molar mass? Mass times molar mass. Molar mass of carbon will be given at 12 gram per mole. Here we have mole. Got a mole of carbon in 0.16 mole of ibuprofen equals to 25 gram of ibuprofen. That's it. This is how we find the mass in grams of any element in a compound. Okay, if I'd ask for hydrogen, 0.16 times 18, you get the mole of hydrogen in 0.16 mole of ibuprofen. Mole times 18 times 0.16, you get a number, times the molar mass of hydrogen, you get the mass of hydrogen. For oxygen, we use the same way. That's it. And also here, this is the steps that we do. Mole of ibuprofen times the 13 mole of carbon in 1 mole. In 1 mole, we have 13. What about in 0.16 mole? It's like cross product. In 1 mole, 13 carbons. What about in 0.16 mole? 0.16 times 13. That's it. Times the molar mass of carbon. Guys, for the practice questions, just note the third one. Mole is given, it asks for mass. But to know the molar mass of any compound, you need to know the chemical formula. What's the chemical formula of copper nitrate? We have learned in section 1. This is CuNO3, because NO3 in a bracket 2. Why? Because the charge of copper is 2 positive. Okay, that's it. Then you're going to find the molar mass of copper nitrate. You have 1 copper, 2 nitrogen, 6 oxygens. Okay, so use the steps that 2 nitrogen, 2 times 14, 6 oxygen, 6 times 16, 1 copper, 1 times the molar mass of copper. Add all together, you get the molar mass of copper nitrate. That number multiplied by the mole, you get what? You get the mass, which is 1170 gram about. If you get less than that number or more than 71, 72, it's okay. So for this question, again, you need the molar mass. You have learned how to find the molar mass of any compound. Here, guys, how many molecules are there in 25 gram of sulfuric acid? You need, it asks for number of molecules, but gram is given. So we need to find mole, we need to change gram to mole of any, so we have gram of sulfuric acid. we need to change mole, because to find number of molecules, mole times Avogadro's number, you get the number of molecules. But mole is a noun. We change 25 gram to mole. So 25 gram divide by molar mass of H2SO4. You get the what? You get the molar mass of sulfuric acid. 25 divided by the sulfuric acid's molar mass, you get the mole. That number multiplied by Avogadro's number, you get the number, how many molecules in 25 gram of sulfuric acid. That's the end of the video. Thanks for watching. See you next time.